Welcome second year B.Sc student, paper number MTS 301, calculus of several variable, video number 26, unit number 3, Taylor's theorem and extreme value, and this is video of extreme value. Dear friend, first subscribe my YouTube channel PV Patil. Extreme value, minimum and maximum value of function are called extreme value, means highest value and lowest value of the function are called extreme value. Now method to find extreme value, let f of xy be given function, fxab equal to 0 and fyab equal to 0. Let f_xab equal to r, f of xyab equal to s, f_yab equal to t, and delta equal to rt minus s square. Then number 1, f of ab is minimum if delta is positive and r is positive. F of ab is maximum if delta positive and r negative. AB is a saddle point if delta negative, and case is doubtful if delta equal to 0. Means for extreme value means find maximum and minimum value. So for that, first find 5 derivatives fx, fy, f_x, f of xy, f_y. Then first take fx equal to 0 and fy equal to 0 and find the point AB. First take fx 0, fy 0 and find out point AB. This point is called as critical point or stationary point AB. Then find out r, s and t, and delta equal to rt minus s square. And if delta positive, r positive, then function is minimum. If delta positive, r negative, function is maximum. If delta negative, then saddle point, means neither maximum nor minimum at that point, and delta equal to 0, then case is doubtful. Example 1, find the extreme value of f of xy is equal to xy plus 50 upon x plus 20 upon y. Find the extreme value of this function, means find highest and lowest value, means maximum and minimum value of the function. So for that, first write down given function f of xy equal to xy plus 50 upon x plus 20 upon y. Then by using this, first find out 5 derivatives, first one fx, then fy, f_x, f of xy and f_y. Therefore fx equal to partial derivative of this function with respect to x, derivative of xy is y, plus 50, derivative of 1 upon x is minus 1 upon x square, and derivative of 20 upon y is 0. Then fy, partial derivative of f with respect to y, derivative of xy with respect to y is x, then derivative of 50 upon x is 0, plus 20, and derivative of 1 upon y is minus 1 upon y square, so minus 20 upon y square. Then find out f_x, double derivative of this function, means derivative of function fx, derivative of y 0, minus 50, and derivative of 1 upon x square, means derivative of x raised to minus 2 is minus 2 x raised to minus 3, means this become minus and minus plus 100 upon x cube. Then f of xy means partial derivative of fy with respect to x, derivative of fy with respect to x is 1, and derivative of 20 upon y square is 0, so f of xy is 1. Next one f_y, partial derivative of fy with respect to y, derivative of x 0, then minus 20 constant, then minus 20 constant, derivative of 1 upon y square, means derivative of y raised to minus 2 is minus 2 y raised to minus 3, means minus 2 into minus 20 is plus 40 upon y cube, plus 40 upon y cube. Then first take fx 0 and fy 0. Take fx 0, fy 0, find the critical point. For extreme value, take fx equal to 0, fy equal to 0. Fx is y minus 50 upon x square equal to 0, and fy is x minus 20 upon y square equal to 0. So we get y is equal to y equal to this term on right hand side become 50 upon x square, and x equal to this term on right hand side become 20 upon y square. Y is 50 upon x square, x equal to 20 upon y square. Solve these two equations. Solve these two equations, find the value of x and y, we get stationary point means critical point. Solve these equations. So first take their product of these two equations. So y into x equal to 50 upon x square into 20 upon y square means product of these two equations. Y into x equal to 50 upon x square, 20 upon y square. Therefore we get xy equal to 1000 upon x square y square. Xy equal to 1000 upon x square y square. Now cross multiply. Xy into x square y square is x cube y cube. X cube y cube and 1000 is 10 cube. X cube y cube equal to 10 cube. So xy equal to 10. Taking cube root of both sides, we get xy equal to 10. Now we get xy equal to 10. Now find the value of x or y by using this. By using this, find the value of x and y. So for that, divide this equation by y equal to 50 upon x square. Means xy upon y equal to xy upon y equal to 10 upon 50 upon x square. Xy upon y equal to 10 upon 50 upon x square. Y cancel, we get x equal to x square is in numerator, x square by 5. X square in numerator, x square by 5. Therefore we get 1x cancel. So we get x 5 equal to x. We get 5 equal to x. 1x cancel, we get 5 equal to x. So x is 5. Now put the value of x is 5 here. Put the value of x is 5. So y equal to 50 upon 5 square. X is 5. So y equal to 50 upon 5 square. So 50 upon 25 is 2. X is 5, y is 2 is a critical point. 5, 2. Value of x means x coordinate, value of y means y coordinate. So point 52 is a stationary point. Now at that point, find the value of f double x, f of xy, f double y. We know these values as r, s and t. Now we know r equal to f double x at 0.52. Now we know f double x is 100 upon x cube. F double x is 100 upon x cube. Put the value of x is 5 and y is 2. X is 5. So equal to 100 upon 5 cube means 100 upon 125. Divide by 25, we get 4 by 5. We get r equal to 4 by 5. Now s is f of xy at 0.52. Now we know f of xy is 1. So f of xy at 0.52 is also same value 1. Then t is f double y. T is f double y at the 0.52. We know f double y is 40 upon y cube. Put the value of x is 5 and y is 2 here. So equal to 40 upon 2 cube means equal to 40 upon 8 and is equal to 5. Then find the value of delta. We know delta equal to RT minus S square. Put the value of R is 4 by 5. Value of T is 5 and value of S is 1. We get 4 upon 5 into 5 minus 1 square. Is 4 minus 1 and equal to 3. Mean delta equal to 3 and this is positive value plus value mean delta positive and R is also positive. Delta positive, R positive, therefore function f is minimum at 0.52 and minimum value of function means f minimum is f of 52. F minimum is f of 52. We know function f of xy plus 50 upon x plus 20 upon y. Here put x is 5 and y equal to 2. In function f of xy, put x is 5, y is 2. So equal to 5 into 2 plus 50 upon 5 plus 20 upon 2 is equal to 10 plus 10 plus 10 and is equal to 30. 30 is minimum value of given function f of xy. Next example number 2. Find the extreme value of f of xy equal to xy into bracket a minus x minus y. So for that, first write down given function f of xy equal to xy into bracket a minus x minus y. Now to find derivative fx, fy, f double x, f of xy, f double y. Before that, first open this bracket, take their product. So first term is axy, second term is xy into x is minus of x square y. Next term is xy into minus y is minus xy square. Then find out fx, partial derivative of function f with respect to x is ay minus 2xy minus y square. Then next one, find out fy, partial derivative of function f with respect to y is ax minus x square minus 2xy. Then f double x, derivative of fx is f double x, derivative of fx, so partial derivative of ay 0 minus 2y, derivative of x is 1, so minus 2y, derivative of y square 0. Then f of xy means partial derivative of fy with respect to x, derivative of this function with respect to x is a minus 2x and minus 2y. Then f double y, partial derivative of fy with respect to y, derivative of ax 0, derivative of x square 0, minus 2x and derivative of y is 1, so remains only minus 2x. Then for extreme value, take first fx 0 and fy 0 and find the stationary points. For extreme value, take fx 0, fy 0. Now fx means ay minus 2x minus y square equal to 0, and fy is ax minus x square minus 2xy equal to 0. Now solve these two equations and find the values of x and y, means we get stationary point. So again write down same equation here. Now solve these two equations. On the first equation taking y common, and on second equation x common. Therefore we get from the first equation y common inside the bracket a minus 2x minus y equal to 0, and from the second equation x common into bracket a minus x minus 2y equal to 0. Therefore y is 0 or a minus 2x minus y equal to 0. From the first equation either first value 0 or second value 0, and from the second equation x is 0 or a minus x minus 2y equal to 0. Therefore we get y equal to 0 or 2x plus y is equal to a, and x equal to 0 or x plus 2y equal to a. Therefore one point is x is 0, y is 0, means 0 0 is 1 point. Now solve these two equations and find the value of x and y. Solve these two equations. Consider this equation 2x plus y equal to a and x plus 2y equal to a. Consider these two equations. Now solve these two simultaneous equations. So multiply this equation by 2. Multiply this equation by 2, we get 2x plus 4y equal to 2a. Now subtract these two equations. From this equation, subtract this equation, 2x plus 4y minus 2x minus y. 2x cancel, 4y minus y is 3y, and 2a minus a is equal to a. Therefore we get y equal to a by 3. We get y equal to a by 3. Put the value of y in this equation. So this equation become 2x plus a by 3 equal to a. 2x plus a by 3 equal to a. Therefore we get 2x equal to a minus a by 3. 2x equal to a minus a by 3. Take LCM here. LCM is 3. So 3a minus a is 2a by 3. 2x equal to 2a by 3. So we get x equal to a by 3. X is a by 3. Y is a by 3. So we get point is value of x means x coordinate, value of y means y coordinate. So point is a by 3, a by 3. Now first use y is 0 and put the value of y is 0 in this equation. Therefore we get when y equal to 0, this equation x plus 2y equal to a become. Put y equal to 0, we get x equal to a. Point is value of x is x coordinate, value of y is y coordinate, so a0. Now put x equal to 0. When x is 0, the equation 2x plus y equal to a become 0 and y equal to a, y is a. Therefore point is 0a, and therefore we get stationary points are, first point x is 0, y is 0 means 0 0. Next point is a0, then next one 0a, and last point is a by 3, a by 3. We get 4 stationary point. Now find the value of r, s, t and delta at all these 4 points. So for that, prepare one table. First column is stationary point. We get 4 point. First point 0 0, second point a0, next point 0a, and a by 3, a by 3. Then r. R means f double x, and we know f double x is minus 2y. Here put the value of x is 0, y is 0. So y is 0, so this is 0. At that point, value of x is a, y is 0, so this is also 0. At that point, x is 0, y is a, so this become minus 2a. And here put x is a by 3, y is a by 3, so we get minus 2a by 3. This value is negative. Value of r is negative here. Here also r is negative. Now s is f of xy. F of xy, its value is a minus 2x minus 2y. At that point, value of s is a minus 0 means a only. Next point a0, x is a, y is 0. So a minus 2a minus 0 is minus a. At that point x is 0, y is a, so a minus 0 minus 2a become minus a. Now here put x is a by 3, y is a by 3, so a minus 2a by 3 minus 2a by 3. After simplification we get minus a by 3. Now t means f double y. We know f double y is minus 2x. At that point 0 0, x is 0, so this is 0. At point a0 means x is a, so this is minus 2a. At point 0a, x is 0, so this is 0. At point a by 3, x is a by 3, so minus 2a by 3. Therefore delta equal to, now we know formula delta equal to rt minus s square. We know r, t and s. So rt 0 into 0 is 0 minus a square. So minus a square, this value is negative. Delta negative. When delta is negative, this is a saddle point. Next one. At that point, delta equal to rt minus s square. 0 into 2a is 0 minus of minus a square is minus a square. This is also negative. Delta negative. So this is a saddle point. A0 is a saddle point. At that point, rt, r into t is 0. Minus of minus a square is minus a square. This is also negative. Delta negative. So this is also saddle point. Now at that point, rt minus 2a by 3 minus 2a by 3 is 4a square by 9. 4a square by 9 minus of minus a by 3 bracket square is minus a square by 9. Therefore we get 4a square by 9 minus a square by 9 equal to 3a square by 9, means we get a square by 3. This is a positive value. This value is greater than 0. Now delta positive and r negative, so function is maximum. At that point, at point a by 3, function is maximum. Function f of xy is maximum at point a by 3, and f maximum value of function is f of a by 3. Now we know f of xy. F of xy is xy into bracket a minus x minus y. Here put x is a by 3, y is a by 3. So we get a by 3 into a by 3 into bracket a minus a by 3 minus a by 3. So we get a square by 9. Inside the bracket LCM is 3. 3a minus a minus a. A square by 9 into a by 3. A square by 9 and inside the bracket a by 3. So is equal to, we get a cube by 27 is maximum value of the function is final answer. Next, example number 3. Find the extreme value of function f of xy is equal to xy inside the bracket 1 minus x minus y. Means find maximum or minimum value of function. So for that, first write down f of xy equal to xy into bracket 1 minus x minus y. First open this bracket. So we get xy into 1 is xy. Xy into x is minus x square y. Xy into y is minus xy square. This is function f. Then first find out fx, then fy, then f double x, f of xy and f double y. Find out this derivative. So fx equal to partial derivative of f with respect to x is y minus of derivative of x square is 2x into y minus of y square. Now partial derivative of f with respect to y means fy is x minus x square minus 2xy. Then f double x partial derivative of fx with respect to x derivative of y 0 minus 2y minus 0 is minus 2y only. F of xy partial derivative of fy with respect to x is 1 minus 2x minus 2y. Then f double y partial derivative of fy with respect to y 0 minus 2x means only minus 2x. Then for extreme value take fx 0 and fy 0. For extreme value take fx 0, fy 0. Fx is y minus 2xy minus y square equal to 0 and fy is x minus x square minus 2xy equal to 0. Now first write down same expression y minus 2xy minus y square 0 and x minus x square minus 2xy equal to 0. From this first equation here y common and from second equation x common. So we get y into bracket 1 minus 2x minus y equal to 0 and from the second equation x into bracket 1 minus x minus 2y equal to 0. Then either first term 0 or second term 0. So y equal to 0 or 1 minus 2x minus y equal to 0 and x equal to 0 or 1 minus x minus 2y equal to 0. Therefore we get y is 0 or write down this minus term on the right hand side. So we get 2x plus y. 2x plus y is equal to 1 and x is 0 or x plus 2y equal to 1. Now we get 1 point is x is 0, y is 0 means 0, 0 is 1 point. And find out all the next point. First solve these two simultaneous equations. Consider these two equations. Consider the equation 2x plus y equal to 1 and x plus 2y equal to 1. Multiply this second equation by 2. Multiply this equation by 2, we get 2x plus 4y is equal to 2 and from this equation subtract this equation. So 2x plus 4y minus 2x minus y. So 2x cancel, 4y minus y is 3y and 2 minus 1 is 1. 3y equal to 1, so we get y equal to 1 by 3. Put the value of y is 1 by 3 here or here. Now put the value of y is 1 by 3 here, so we get 2x plus 1 by 3 equal to 1. Therefore 2x equal to 1 minus 1 by 3 means LCM 3, so 3 minus 1, 2 by 3. Divide by 2, we get x equal to 1 by 3. So point is 1 by 3 is a point. Now put the value of y equal to 0 in this equation. Now when y equal to 0, this equation x plus 2y equal to 1 become. Put y is 0. So we get x plus 0 is 1 means x equal to 1. So point is value of x coordinate 1 and value of y coordinate 0, 1 0. Now when x is 0, put the value of x is 0 in this equation. When x is 0, equation 2x plus y equal to 1 become Put x is 0, so 0 plus y is 1, so y equal to 1, so point is 0, 1. So we get 4 stationary points here. One point is 0, 0, next point is 1, 0, then 0, 1 and 1 by 3, 1 by 3. We get 4 stationary points in this. Now at all these points, find the value of r, s, t and delta. So for that prepare a table. First column is stationary points. First point 0, 0, 1, 0, 0, 1, 1 by 3, 1 by 3. Second column is r equal to f double x, and we know f double x is minus 2y. At point 0, 0, put y is 0, so this is 0. At point 1, 0, put y is 0, so this is 0. At point 0, 1, put y is 1, so we get minus 2. At point 1 by 3, 1 by 3, put y is 1 by 3, so this become minus 2 by 3. This value is negative and this is also negative. Then next column is s. S equal to f of xy and is equal to 1 minus 2x minus 2y. At point 0, 0, put x is 0, y is 0, so 1 minus 0 is 1. At point 1, 0, put x is 1, y is 0, so 1 minus 2 minus 0 is minus 1. At point 0, 1, put x is 0, y is 1, so 1 minus 0 minus 2 is minus 1. At point 1 by 3, 1 by 3, put x is 1 by 3, y is 1 by 3, we get 1 minus 2 by 3 minus 2 by 3. LCM is 3, so 3 minus 2 minus 2 upon 3 is minus 1 by 3. Now next column is t equal to f double y, and we know f double y is minus 2x. At point 0, 0, x is 0, so this is 0. At point 1, 0, x is 1, so this is minus 2. At point 0, 1, x is 0, so this is 0. At point 1 by 3, 1 by 3, x is 1 by 3, so this become minus 2 by 3. Now delta equal to rt minus s square r into t. 0 into 0 is 0, minus 1 square is minus 1. This is negative. When delta is negative, so point 0, 0 is a saddle point. At the next point 1, 0, rt is 0, minus s square means minus of minus 1 square is minus 1, so delta negative, so this point 1, 0 is also saddle point. At point 0, 1, rt is 0, minus of minus 1 square is minus 1, this is also negative, so this point 0, 1 is also saddle point. And at point 1 by 3, 1 by 3, rt minus 2 by 3 into minus 2 by 3 is 4 by 9. 4 by 9 minus of minus 1 by 3 square is minus 1 by 9. 4 by 9 minus 1 by 9 is 3 by 9. 3 by 9 means 1 by 3. This is positive value, means delta positive, r negative. So at point 1 by 3, 1 by 3 function is maximum, and therefore function f of xy is maximum at point 1 by 3, 1 by 3, and f maximum value of function is f of 1 by 3, 1 by 3. We know f of xy is xy into bracket 1 minus x minus y. Put x is 1 by 3, y is 1 by 3, we get 1 by 3 into 1 by 3 into next bracket 1 minus 1 by 3 minus 1 by 3. So we get equal to 1 upon 9. Inside the bracket LCM is 3, so 3 minus 1 minus 1. So 1 by 9 into bracket 1 by 3, so is equal to 1 upon 27 is maximum value of given function. One problem write down as a homework. Find the extreme value of function f of xy equal to xy plus a cube by x plus a cube by y. Dear friend, subscribe this channel and share to our friend. Thank you.